Hello class, let us prove one more important identity. Gradient U whole transpose C is equal to gradient of U dot C, where C is a constant vector and U is also a vector. U is also a vector. Okay, now very easy proof. Now U is a vector, that means it is tensor of order 1, right? And gradient of U, when you apply a gradient, what is happening to the order? Order will be increased. So it is a tensor of order 2. And the transpose of that is also a tensor of order 2. Right? Then just multiply C to it. Gradient U whole transpose C, this is ordinary multiplication, is a vector. Is a vector. So what is our LHS? We have to prove, gradient U whole transpose is equal to gradient U dot C. We have to prove, right? So let us take the LHS. LHS is a vector. So how many free suffixes it will have? It will have one free suffix, right? And that is nothing but the product of a tensor and a vector C, right? That's nothing but now gradient U transpose, right? Ij, and for C, J will come because I want I here, right? J has to be dummy, right? Now, whole transpose is there. In the next step, we remove the transpose. So when we remove the transpose, what do? We interchange rows and columns. So it is Ji and Cj as it is, and without transpose. Now, gradient U, any two suffixes is nothing but U, the first suffix J, comma I. So U, J, comma I. This is nothing but gradient of U, Ji is nothing but Uj, comma I and Cj as it is. Now in the next step, what we do is very important. We are going to add something. What is that we are going to add? We are going to add, see, the first term is as it is, plus we are going to add something here. So Uj, Cj, comma I. We are going to add this. Now Cj with respect to, differentiation with respect to xi. Now C is what? C is a constant vector. So differentiation with respect to x or, x1, x2, x3, it's nothing but 0 there. So this part is anyway 0 here. This is equal to 0. So we're just adding a 0 to it. So therefore these two are same, right? Now when we add this, what is going to happen? That is equal, now just watch. Differentiation of uj with respect to xi, cj as it is, plus, look at the second term, uj as it is, differentiation of cj with respect to xi, right? So this is nothing but, product, differentiation of, using the product rule, right? So that whole thing is nothing but uj, cj, comma xi, right? That's, is it not the definition of, product rule? Differentiation of uj, cj as it is, plus uj as it is, differentiation of cj, right? So that's nothing but the product rule. So comma I as it is outside the bracket. Now, what is uj, cj? Uj, cj is nothing but u dot c. Uj, cj is nothing but u dot c. Comma I is nothing but gradient of that. Gradient of that. And I here and here also high. Therefore, we have proved gradient u transpose c is nothing but gradient u dot c. Very important identity. Okay guys, let's stop. Let's go to next identity in the next class. Thank you.